Hey, math fans, we're now in Math 2. We're on section 1.1.1. Let's get started. In this section, we're going to discuss exponents and how you can write roots and powers in a fractional exponent. A quick review, remember the base is the factor that's being multiplied together. And then you have the power, for example, 2 to the 5th power would be 2 times itself 5 times, which is 32. A radical expression involves the square root symbol. However, when we put another number in front of it, like take, for example, a 3 that's just outside of the square root symbol, it becomes what's known as a cube root. Or you have to ask yourself, what number times itself 3 times would equal the number inside the radical? And the cube root of 8 would be equal to 2 because 2 to the 3rd power is 8. Powers and roots can be written as a fractional exponent. And in this case, if it's the nth root, x is raised to the m power, it's x to the m over n would be the fractional exponent. The definition of a rational number is a real number that can be written as a fraction. One of the reasons why pi is an irrational number is there's no way to actually write it as a fraction. Some people think that 22 over 7 is equal to pi, but that's actually incorrect. It's an estimate for pi. And that's the closest rational number that people find easy to use to describe the number pi. So we're going to be using an exponential equation. Once again, a to the m over n is really, it means that you're going to take the base a and raise it to the m power, but take the nth root of it. Here are some more properties of exponents. A lot of this is just review. Remember, anything to the 0 power is 1. Remember, negative exponents really mean reciprocal. Product of powers property, remember if you have a base that's the same and you're multiplying those two bases, you will just end up adding the exponents. And then, of course, we have the quotients of powers property. We have the power to a power. Remember, if you're raising something that has an exponent to another power, it's going to get multiplied. And then we also have power of a product property and then power of a quotient property. Okay, so let's take a look at some roots other than square roots, because this is kind of new for us. So we're used to taking the square root, what number times itself will get you the number inside of the radical. However, what if we were to take a look at cube roots? In other words, what number times itself 3 times would get you that number inside the radical? So notice I have some of the first perfect cubes. And as you can see, cube root of 8 is 2. Cube root of 27 is 3. Cube root of 64 is 4. What about fourth roots? Can you take a fourth root? Absolutely. Here are some popular fourth roots. The fourth root of 16 is going to be equal to 2 because 2 times itself 4 times will get you 16. The fourth root of 81 is 3 because 3 times itself 4 times is 81. Here's some more key concepts, and then there's also some common errors and misconceptions at the bottom. Example 1, how can the exponential expression 3 to the 6 over 5 power be written as a radical expression? Well, first thing you need to do is identify what is the root, what is the power. The power will always be in the numerator of the fraction, so the 6 is going to be our power. The root will be in the denominator, so it's going to be the 5th root. So if we're going to write this, it's going to be 5th root of 3 to the 6th power, or the 5th root of 3 raised to the 6th power. How can the radical expression 8th root of a to the c power be rewritten as an exponential expression? So you have a to the c over 8 power. How do you use your scientific calculator in order to do roots other than square roots? Now notice that there is a square root symbol on your calculator, and it's only after you hit the second function button. When you hit that second function button, you can get the things that are in blue or some other color that are above the other keys. The button that's right above the x squared and the square root button is the root button. And so the caret symbol represents exponent, and so the radical with the square root, and then it has a little x right there, is going to represent our root button. So on your calculator, you're going to be using the second function and then the caret symbol, which is that arrow, to get to that root button. However, you're going to need to push the root number first. So I have an example here. If you want the cube root of 27, you're going to actually have to type in the number 3, then hit second function caret button to get that root. And make sure it's got the x. If it doesn't have the x, that means it's just going to be the square root. And we want the cube root. We don't want to know what number times itself just twice will get me 27. I want to know what number times itself 3 times will get me 27. So make sure it has that x next to the radical. If I want to find the 5th root of 1024, again, type the number 5. I'm going to hit the second function button, caret, which will get me the root symbol, and that will give me the 5th root of 1024. The cool thing about your calculator is that you can use the caret button to do fractional exponents. Not only can you raise it to any power, but you can also raise a number to a fractional exponent. So the caret symbol is located right here. Looks like an arrow going up. And just please make sure to use parentheses around the fraction. Otherwise, your calculator is going to think to raise 64 to the second power and then divide all of it by 3. And that's not what we want. We want 64 raised to the 2 over 3 power. So please use those parentheses. All right, example 3 says evaluate the expression, the 8th root of 4 to the 10th power. And then it says round your number to the nearest thousandth. So this is a hint that we're going to be using our scientific calculator for this. So a couple different ways you can do it. You can actually raise 4 to the 10th power, which is going to be this ginormous number, and then take the 8th root of that on your calculator. Or you could just type into your calculator 4 caret and then parentheses 10 over 8 and also get the same number, but you got to use those parentheses. And then finally, a real life example. What's the town's approximate population 2.5 years after the year 2000? Well, this becomes pretty simple. All we need to do is take the 2.5 and plug that in for the amount of time. That's the number of years past the year 2000. And your calculator will handle this just on your own. I think the reason they put this problem in the section is, will you get the same answer if you use a fractional exponent of 5 over 2? The answer is yes. So both of these will get you that approximate population of 3,612 people. Please don't forget to use those parentheses when you're doing fractional exponents on your calculator. And that's going to do it for this section. We'll see you in class.